Welcome, everybody. This tutorial is called Putting ICU to Work. I'm Elango Cheran. I'm an internationalization engineer at Google. I contribute to the ICU technical committee, and I've also contributed to ICU for X and other working groups within Unicode. Markus Scherer will be my trusty assistant. So if I start to wander off the beaten path, he'll bring me back. Markus, is there anything that you want to mention about yourself?
Hi, just briefly, my name is Markus Scherer. I've been working on ICU for about 26 years. I'm the technical committee chair, also dabble in other parts of Unicode, properties and algorithms and stuff like that. And I also work at Google.
All right, thanks. So this tutorial will help you get a better sense of how we can handle Unicode text. We'll learn about ICU, which is International Components for Unicode, which is a popular library. I'd go so far as to say it's one of the most popular libraries for internationalization. If you saw Joel's tutorial earlier about introduction to internationalization and Unicode internationalization technologies, you would have seen all the places in which ICU is already deployed. So if you're creating an application that's running on Mac OS, iOS, Windows, Linux, Chrome OS is Linux, Android, iOS is built into those frameworks. ICU is built into those frameworks. So it's everywhere you want to be. And we'll see how Unicode is more than just Unicode, and ICU is a companion to that to actually make it practical in the technology applications that we use. So can I just use Unicode and be done? Like I've seen UTF-8, I've been able to save files in UTF-8, isn't that it? And there's a lot more to Unicode. Now, this is a picture of a pile of books that talk about languages and different scripts. And then you also see the big book that's the 5th edition of the Unicode standard, which is several years ago. And at that time, on this scale, it looks like this scale was coming out to 39 pounds, I think would be the unit. We're in the 17th version of Unicode. So there's a little bit more going on than what we think, because what we think of Unicode is charts. You know, there's, as you know, like all the characters that it takes to represent all the languages in the world, and every character gets its own number. So we have charts to show that. You have the whole grids of numbers and all the characters. And at one level, yes, that's Unicode, but there's so much more that needs to happen to make this something useful, even in the standards. So that's what core represents. So core is talking about is the standard, and that represents all the, the do's and don'ts, all the principles of it, explaining everything, and some of the algorithms and so on. And then there's annexes. So there are more algorithms. There's more specifications that we continually find that we need to add, to update. So there's a lot. And I think if there were a printed version of Unicode 17, it would probably be much larger than that book right there. But I think at the time being, I hope these numbers are right, we're almost at 160,000 assigned characters. But that number increases every year. Because every year there's an update. We are adding new characters, new scripts, and a new script obviously will include more characters. And in addition, there are properties. At the time that this was written, this has 80 plus character properties. I think by my rough count, it's more than 100 character properties. So for all the assigned characters, people at Unicode are figuring out what the value for each of those properties should be for that character. And we're doing this for all the characters. So there's a lot of data that goes in. And that's what powers all the algorithms that we'll take a look at later. But a lot of the Unicode work also is interfacing with different additional standards and geopolitical requirements. So CLDR is kind of where we store all of our locale data, but there's this synchrony with ISO and the ISO standard. So Unicode and ISO have this official handshake type of process, so that the Unicode work becomes an international standard and continues to be updated. When there are time zone updates, ICU will pull in that time zone data and make it available to users of ICU. Time zones are an interesting thing, and there aren't necessarily international processes that govern it, but political entities will be like, oh, you know what, in our region, we're going to change time zones for whatever reason. And how it gets into technology, ICU is the way that we incorporate it. So good and fast. It's one thing to take your programming knowledge that you learn from school and implement something that's good and correct. But there's also an element of making sure that it's fast enough so that when it's running on all of our devices, including these mobile devices, this thing is actually good enough that we can use these things in a reasonable way. It's snappy, it's fast. It's incredible to see how highly optimized the code is in ICU to do these low-level things that are the building blocks for the technology that renders the text in your phone and that makes text usable. So ICU is just a building block, but we'll see that there's so many things like fonts, rendering, like text rendering engines and so on, that build upon all these character properties and algorithms. And without these underlying things that ICU provides being super fast, those things would be super sluggish, and we'd be still kind of struggling. So at its most basic, like from the Unicode website, Unicode covers the world. And at its most basic principle, Unicode provides a unique number for every character, no matter what the platform, no matter what the program, no matter what the language. But ICU brings you home. Requirements vary widely across languages and countries. So just to give you a couple of examples to illustrate this, with languages, we can imagine and appreciate how things can differ. So let's say you take a number and you have, you're going to a restaurant, you see prices, and those prices are numbers, those are currencies in particular, or just a number, you're doing math. And in English, if you wrote the number 1000, you might write 1,000. So the comma is a grouping separator. If you're taking German, it would be 1.000. Okay. Well, okay, what if you write fractions? In English, you would say pi is 3 point, decimal point, 14159, so on. But in German, the dot is actually now a comma. They would do 3,14159. So right there, like just between two languages, this thing, how you format a number can get kind of, it can be the opposite, very backwards. But even within a language, but across regions and countries, you have different behavior. Like America likes to do things differently, so we continue to format dates with the month, then the day, then the year, and a lot of the rest of the world doesn't. So America does that, but I think in the UK, they would probably do the day, then the month. And Canada used to do the day, then the month, but now maybe the American version of month and day is starting to become more prevalent. So these things vary, and they change over time. So, remembering this stuff is really tricky, and it's great if you can just use a library, feed it the date, feed it the number, feed it the currency, and let it do the right thing. Now, it's not just dates and numbers and times and currencies. There's also sorting, and searching is actually related to sorting. But sorting of text is actually very language specific, and maybe we'll get to an example. But bidirectional text processing, a lot of languages are left to right, but when you are mixing right to left and left to right languages, sorry about that, then it gets really interesting really fast how you have to treat your text. If you have right to left text, like let's say you have Arabic or Hebrew, but you do have a number that's using Latin digits, like the 0, 1 through 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 that we're used to, and you put that in the middle of that text, you would read right to left. And then when you get to that number, you actually read that number left to right. And once you're finished reading that number, you go back to reading right to left again. But that requires, so for a computer system to represent that text properly, you need to have this algorithms that ICU provides. There's a lot more functionality, and there are a lot of algorithms that underlie that functionality. So ICU, IC Unicode. A short history of ICU. This is incredibly abbreviated history, but it used to be a project. I think that was a collaboration between Apple and IBM, and then yada yada yada. 1999, IBM releases it to the open source world. So it was internally called IBM Classes for Unicode at some point, and then they renamed it International Components for Unicode, so that it's no longer branded IBM specifically. So that's open source friendly. 2016, sort of the de facto reality that this was and has more or less always been kind of a companion to how Unicode does things, became more official when Unicode became the host of the ICU project officially. The license kind of was a Unicode license, and I guess, is that when the ICU-TC technical committee was formed? Or... Oh, okay. Okay, so Markus is saying when they... Yeah.
So yes, when we previously we had been sponsored by IBM, and then in 2016 we moved from being an IBM hosted project to Unicode hosted project. That's when we became a technical committee. Next to UTC and CLDR technical committee at the time, now we have another new one. By the way, the IBM classes for Unicode stuck around for at least another year, I think, after open source, but we realized that we had to change the name, but we kept the acronym.
Okay, yeah, it's a backronym. And in 2018, we were slowly moving forward through the 21st century. We were starting to use modern processes, and that transition continues. We're getting better and better. This is a more comprehensive listing of the things that ICU does, and this is out of date. There's more than what's on this page. Some of the things that I mentioned, as well as segmenting text. If you're in the localization world, translation world, the tools that you use to do your translation will take a huge document and split it up into sentences. You'll kind of be, you get to price how much work you do by the number of words that you translate. That segmentation of splitting things up into sentences for the purposes of text units, splitting that up into words for the purposes of estimation of prices, that segmentation is implemented in ICU. Yeah, and there's more calendars and time zones, et cetera. So this is the library that you want to use to do these culturally, regionally specific things, linguistically specific things, and just have the library take care of all of the quirks and nuances of human language, which are far greater than I ever thought imaginable, and I'm learning more and more all the time. So the benefits of ICU, it's kind of that set it and forget it. Like I can just pass things on and let it do the right thing. It's always going to be up to date. It is going to be one of the most performant implementations that you'll get. It'll always be correct to the algorithms as much as we can make it. And if you notice bugs, we'll show you how to file bugs so that we can fix them. It's portable because we've got an implementation in Java, we got an implementation in C, C++. And then, as Joel mentioned, there are a lot of wrapper libraries and all these different programming languages around the C library. So the fact that it's an open source means you can do what you want with it. The open source, and within open source licenses, there are some that come with certain opinionated strings and attached, and there are some that are just like, do what you want. And the MIT license that the Unicode license is based on is one of those that fit in the category of do what you want. And that's great because it has no restrictions on who can contribute and who can use it and how they can use it. And so that opens the door for people like you and me, but also big companies throughout the years to become regular heavy contributors. So we have IBM, Google, Apple, Microsoft. They all contribute, they all use it. And that's why they're in all of the devices that we use today. And it's sponsored by Unicode. We know that it will adhere to the latest standards. So where do I get it? The official homepage is icu.unicode.org. And you can find links on how to get involved, how to download it, where to get the API documentation if you're a developer, and how to go to the user guide. So the user guide's a separate site, but I hope that the next time this tutorial is given, we'll have an all-in-one site that is easier to use and has everything and go a long way to explaining all this stuff. Now, the best way to build ICU is to have someone build it for you. So it's easy to install it. If you're an ICU for C, you can get it through your operating system package manager, and you can install that library so you can develop against it. If you're in the Java world, then you have the legacy of the IBM project. So in the Java world, a lot of code is packaged up into artifacts, as they call them, in the Maven world. Maven's a tool for building, but also distributing these shared artifacts. So the group name is com.ibm ICU, and the artifact ID is ICU for J. So ICU for J is what we would call the Java portion of the code base. ICU for C is what we call the C++ portion of the code base, and they implement the same functionality, just different programming languages, so they target different places. The user guide has a lot of explanation of the concepts that are involved in ICU. So definitely it's a great place to learn, and we're going to make that even better and better as time goes on. There's also documentation that you can get where you can find more details about the CLDR data that powers ICU and how to get the details there. If you're a developer, you can hit our API docs. We have them for ICU for C, ICU for J, and as just like any other developer docs, for all the functions that you have, what are the inputs, what are the outputs, what does this thing do, how's it supposed to work? If you want an API, like if you are, again, are a developer and you're wanting to know how do things change over time, ICU does a really good job of being backwards compatible, but it is good just to know like our APIs, what's being added, what's the progress of the status, like is it a draft, is it final, is this thing stabilized now? So you can find that for every release and see how this release has added or stabilized things from the previous release. When we do have a new release, you can go to the user guide right now and go to the download page, and then you can see the latest information, the information about the latest release, and you can see previous releases. This is a screenshot showing ICU 78, and as you can see, that was October 30th, 2025, so not that long ago. And yeah, you can go there and you can see what's new in the latest ICU. And you can get involved. You can ask questions on the ICU support list. You can, if you're proposing changes, you can propose an API design doc in the ICU design list, or you can just subscribe to announcements to see, hey, when is ICU, like when ICU 79 comes out, to be notified and so on. If you want to file a bug report because you know something is wrong, if it's ICU specific, then you can go to Jira. Jira is the name of the tool for bug tracking, and you can select, this is the Unicode Jira project, say that, or Unicode instance, and you would say ICU bug, select a functionality component, maybe it's related to date formatting, so you'd say format date, title description. And the source code lives on GitHub, as I said, github.com/unicode-org/ICU. And just like in a typical open source fashion, if you want to contribute a pull request, and it could be something as small as, hey, there's a typo in the docs, or it could be, hey, I see a bug, and not only am I filing a ticket, but I want to fix it, and here's the fix. We welcome all of it, and we do our best to get to it as soon as we can, and incorporate your changes. So in a typical open source style, you kind of fork, contribute a branch, create a pull request, sign the CLA, and merge. The contributing.md, there's a markdown file at the root called contributing, and that has more detailed information if you want to contribute. And once you do, bask in your newfound fame and fortune. You will be forever in ICU. All right, so we want to do this hands-on and interactively, so let's get to some code. When these slides were written, these Docker instances, I'm sure we're working with the samples, but the second one doesn't work. But I have a different setup, so I'm going to ignore that. you no longer need git LFS for anybody who's checking out. So it's a lot simpler to check out the code base. But if you wanted to build ICU for C, so we use the GNU auto tools. So you do configure, make install. You can clone the repo, and then compile and do all that. And so if you do that, let's see, where is that? So if you were to do all of those steps, then when you do, if you do configure make, and then you do make install, and you configure the directory to be, in my case, I did home/install, then in the lib directory, you get all of these shared libraries. You can see, so I actually cloned the latest on main as of a couple days ago. Because the ICU 78 release has been made and now we're developing for 79, we have a kind of a preview version in our code base. So that's why it says 79.0.1. It's kind of a preview version before we get to the full release, which would be called 79.1. So that's why the version says 79. It hasn't been released. This is in development. So this is the latest, greatest. And then this says, now once you have your installation path, you can set your environment variables, in particular the LD library path. So if I've already set that here, so that is this directory. So I said, okay, LD library path equals my install directory /lib, and it's set. And so now, if I go to the compiled binary directory and I say ICU info, then it runs the tool. So ICU info just dumps a bunch of property information about this current release of ICU. Like I said, it's a kind of an in development version. What version of Unicode data is it using? It's using 17.0. What's the default locale on the system? EN US. That EN is the language code, stands for English. US is the region, stands for United States, and so on. So you have all this information about ICU for C right now. So yeah, we can compile, we can install our manually compiled binary and run some stuff. But if you've got a system, hey, and if the version of Unicode data isn't all that necessary because you're not doing you're not using an algorithm or creating an application that needs the newest, latest, greatest data, any old version will do. Well, then just get it from the package manager. And depending on what operating system you're using, what package manager you have, you can get ICU for C that way. All right, so let's start doing some stuff on our own. Okay, so we're an application developer. We want to display a list of world regions with their population figures. And so we do have that data. I think that data is in CLDR. Correct me if I'm wrong. But I think that data comes from CLDR. And so these numbers were true as of, I don't know, maybe 5 years ago. So we have population data for regions, Algeria, Ecuador, Ceuta, and Melilla. And so let's take a look at what it looks like to do this in ICU for C. So first, just get the basics of a program in ICU for C. So we'll notice that the header files are all in the Unicode directory. So all your pound includes will say Unicode / something something. ICU is a library that for many reasons chose not to use or maybe didn't have the option to use exception handling. So instead we use error codes, and that's our substitute. It's more performant, but it means that we have to manually handle that stuff and check for it because it's not being done automatically. Markus, you want to say something?
Yeah, I want to add that part of the code feeds into a C API, and if C API is important because if you use a shared library or a DLL in Windows language, the C API gives you stable exports. So you can upgrade the ICU DLL, and the entry point symbols will be the same from one version to another. Caveat, by default, we add the version number to the symbols so that you can actually use multiple ICUs at the same time. If you don't need that, you can turn that off. But because of the C code, and also because 25 years ago, a lot of compilers didn't reliably support C++ exceptions, we have this sort of poor man's exception mechanism, which is this error code. Logically speaking, it wants to behave roughly kind of like it, as much as you can make it with this kind of thing. But that's why it's the C APIs. Originally, a lot of the implementation code was also in C. We've changed that over time, although some of it still looks like C, but it's in CPP files. And then old compiler restrictions. And because we have stable API, we can't just toss that overboard and start using exceptions.
Yeah, so there are reasons why if you're a C++ developer and you look at it, you're like, oh, this doesn't have all my creature comforts that I'm used to, but there are reasons. I mean, I think ICU's longevity and its insistence on using being backwards compatible and not breaking people is important because everybody depends on it. So maintaining that principle is incredibly useful, but the downside is if you're a contributor, then you just have to kind of hold your nose on certain things and just kind of deal with it. But it's not the end of the world. So when you do create this error code, you kind of initialize it, and then functions that could cause an error will take it as an argument. So here, this uinit function will load ICU data. So you initialize your ICU data loading. And maybe if you're loading things, like something could go wrong. So you pass in the error code, you pass it by reference with the ampersand. So this function will then let you know by modifying that if something goes wrong. Okay, well, if something goes wrong, how do we know? What do? We have to check for it. So that's where the if statement comes in. So you have this macro that takes that error code and then will tell you if everything is okay or not, and says true if everything's okay, otherwise not. In C++, it's a little bit easier, but I think we tend to use the macros still to check for error code, happiness, success, or failure of some sort. So in some of this sample code, we'll use this macro called assert OK. So whether it's C or C++, assert OK will do the right thing. But yes, definitely check for failure because no one's automatically throwing things at you. So yeah, we're going to use this macro for our sample code. All right, so here's a test program or a sample program. This is in C, and yeah, it says this is ICU %s cat emoji, and then ICU version. So what do you think this is going to print out? I guess it depends on what ICU version you think this is running. Well, let's find out. All right, so I've cloned the repo of the samples. So we're looking at S09 test. I've already run make at the root, so all of the make files in the subdirectories, including this one, have already been compiled. So let's take a look at that source file. So that looks about right. And this looks like what we were just looking at. Is that right? Yeah, that's mostly it. Okay, now let's pull up a terminal. Go into that directory, S09. And what do we get? This is ICU 74.2 cat emoji. And then after that, we look at the success status. So status came from what? Status could have been modified when we were loading data. So when it says everything is okay, we're testing whether uinit successfully loaded the data and didn't have any problems. So that's what that represents. Everything is okay. The data loading is fine. Otherwise, we would have seen something different. But things worked out. When these slides were written, it was 69.1. Yeah, but that's okay. Let's actually build this. So I've already done this work to clone the repo and to do make at the root. And underlying that make commands was actually this particular call to the C compiler to set all the paths and everything. All right, so let's move on to the next example. So this is hello. And if you've done programming, you know that hello world is sort of this, I don't know, very typical thing to get started in a new language, a new framework. You kind of print hello world. But we're going to do the internationalization version of this. So we can see this is going to be C++. So we're looking at the C++ style. We have the ICU namespace. We're creating a locale. We're creating a locale object called locale. UND is means kind of an undefined language. It doesn't mean anything in particular. But 001 is a region. It represents the entire world. Okay, so we're creating a locale. No, we're not specifying the language, but it is referring to the entire world as a region. Now we're setting up a string called a Unicode string. This is, for people who are familiar, this matches how Java strings and characters work. So it's UTF-16 encoded. If that doesn't make sense, don't worry about it. But in ICU for C, all our strings are Unicode strings so that they can play nicely with all the cool functionality that ICU provides. So we typically want to set up a Unicode string, and we do here, but it's empty right now, if you will. And now we're actually doing something interesting. So we're taking our locale, and there's a method called getDisplayCountry, and then we're passing in the string that we want the formatted string result to go into. Now what getDisplayCountry will do is it'll take a look at the locale, and it will find the display name for that region, and then that's what will go into the string. So we haven't specified the locale, so we're using the default locale. And if you remember, the default locale is going to be in English. So we're going to expect an English display name for this region, which is the world. But whatever that is, it's going to be in the word world. And then we're going to check to make sure that we haven't screwed anything up. And then we're going to print if everything looks good. So let's try that. And run it. Oops, sorry. That is because I was playing around with this stuff, and so let me undo my changes, recompile. There we go. All right, it does what it says, hello world. Now I've kind of foreshadowed maybe some interesting stuff that can happen, but let's take it step by step. Okay, hello world. That's all good. Now, what's interesting is that we don't hard code things and have to recompile our code. We want to write code that we can just reuse. And as Joel mentioned, like a properly internationalized application would allow you to flip a switch and then get different behavior without having to touch your code. So in this case, this is setting an environment variable called lc_all, and it's giving a language code to it, and then it's running the application. And it's doing that all in one line. You could do it in separate lines, but ES is the language code for Spanish, and we're going to get hello mundo. So let's actually make sure that that is the case. So lc_all equals ES, and that's what we're getting. So what's going on is that we're setting the default locale, and then that default locale is being used internally by ICU to load the display name data for that locale. And then it's automatically returning that back to us. All right, so this is pretty good. Can we do something in Maltese? And if anybody knows Maltese, then you can confirm if this is correct. And we have, what is ZH, the language code for? And Chinese, and there are different regions, right? And there are different scripts. There's the simplified and there's the traditional. There are different region names. The ZH has an implicit default of simplified Han script in the region of China. So is that correct for world in Chinese? Okay, mainly China. Okay, good. So yeah, I don't even know, but I kind of trust it to be correct. And there's a whole world of people that depend on this stuff being correct, or they're going to complain. So, right, like these functions are being used billions of times a day, and that's no exaggeration. So that gives me the confidence that this stuff works. Okay, but we're doing something wrong here, right? Like something's wrong with this. Do you not see that? Yeah. Why are we saying hello? That doesn't seem localized to me. So what if we want to change that? Okay. This is for anybody who's like, even if you're not an engineer, if you're a translator, if you're localization program manager of any sort, this is a rookie mistake. And if you please just like, if you don't remember anything, just remember this, don't concatenate strings. It's just like, you're setting yourself up for failure because you don't even know the basics. So now you do. The order of words and languages become very, very different. So this is an example of another sentence in English. My aunt's pen is on the table. Okay, and now take a look at aunts. Aunts is an adjective, a possessive adjective, and pen is a noun. And if you can naively say, oh, okay, well, my aunt's pen is on the table. My aunt's napkin is on the table. My brother's napkin is on the table. So then I can hard code this. I can write code that says whom apostrophe s space plus what is on the where. And that works until it doesn't. Then you have Spanish, where I have pluma. I didn't write this. I don't know Spanish, but again, I'm pretty sure that adjectives come after the noun in Spanish. So now it's la pluma de mi tía está sobre la mesa. So now it's all in a different order. What's interesting is this is just adjectives and nouns, but when you look at the sentence level, you have subject, verb, object, and both of these languages adhere to that. But there are plenty of languages that do subject, object, and then the verb goes at the end. And when you think about subject, object, verb, and you permute them, there are 6 different permutations. And interestingly enough, the breadth of human languages covers all 6 different permutations of those grammatical orderings of subject, verb, and object. So there's no way that you can hard code this stuff in code and pretend like it's ever going to work universally. So what we want to do is we don't want to hard code stuff. We want to actually just create a template for the message. So now we can, if we use this syntax for creating messages, we put little curly braces around a placeholder. Then we can say whom's what is on the where. It's a lot simpler and readable. We kind of know what's going on. Then Spanish, it'll be what de whom está sobre la where, period. I mean, another way of handling it is just to not even put grammar at all in there, just kind of throw a bunch of data, but that's not really user-friendly. I guess it really just depends on what you're trying to do. So we have a program to do that. So now we're delving into the world of message formatting. And this is going to be important. This is how you go from being a rookie to properly internationalizing your code. So hello message.cpp, let's get there. All right, so what do we have? So we start off with initializing our error code. We're creating something called names. Names is going to be an object containing locale display names. So we've already seen a display name for world, right? And we saw what happens when we change the default locale. But here again, we're explicitly just getting the default locale. We're not specifying anything specific about what the locale should be. Making sure that we got something when we tried to load the data. That's all good. Okay, setting up that Unicode string for the result. And then here's where we're doing a similar operation. Now it's in C++. Say names, get the region display name. That region, again, represents the world. Store that in the world. So now we have a variable called world. And it's going to be the display name for 001 region. So all of this should be familiar. Now we're using the message formatting construct. So I'll skip around. Here down below, we're going to create our message format object. So message format takes a template string, as you just saw. That's our pattern. It takes a locale, and then we provided the error code just in case things go wrong. So we have a template, but the template can't be realized until we actually give it values to interpolate, right? We have these placeholders, but we need to actually give values of what those placeholders should be at the time that we want. So that's what this stuff is. So this stuff is saying, okay, I'm going to set up my arguments. So arguments is going to be, in this case, an array, or it's in a map. But arguments will say, when I have the label world, I'm going to associate that with this. So when I see the string world in the pattern, I'm going to put in that, I'm going to associate that with the actual runtime value of whatever my Unicode string was, whatever I got back from the CLDR data. So that's all fine and good. So we have this message formatter, we call format on it, and we have the template baked in, the pattern baked in. Now we give it the runtime values. They're the runtime values, the list of names to associate with those values. And we're going to print out the result. OK, now we've got another one. So if that was message en, we have message es for Spanish. And in this case, instead of hello, we have hola. And instead of an exclamation point at the end, we also have, as in Spanish, that kind of reverse rotated version that you put at the beginning of the sentence. And for this, we do the same stuff. And we're going to format. So what do we get? OK, hello world and hola world. All right. That's what we expected. But what if I want to change the target language? Because we pulled out that world, but what we should expect is I want to see what it looks like in Spanish. So lc all equals es, and then run the program. And now we get hello mundo, and we get hola mundo. So when you do create a formatted message, you actually want to make sure that you specify the target language so that your other pieces of information will come out as you expect. If you have a number in your pattern, as we'll see later, or is it a date? When you have other things in your pattern, specifying the locale of the target language will ensure that you get the things that you expect. All right, so we've seen a bit of C and C++. Let's take a look at Java. And like I said, our Java code base, we tend to refer to as ICU for J, but it's all one ICU. If you're familiar with the Maven stuff, here are the coordinates that you can look at. This is using 74.2. So I'll update these slides and have that accurate. So we have a hello Java. So I have IntelliJ, not VS Code, to run my Java stuff. I have the samples here, at least for the Java side. I've imported that as a Maven project. And let's just take a look first before we pull it up and run anything. So what do we expect? We're going to get a default locale. We've been doing that in C, C++. Locale display names, all right, that sounds familiar too. We've been doing that. Get instance for the default locale and region display name, all right. And this time we'll be cute and we'll throw in an escape sequence. So this is going to use the hex version of the integer of the code point in Unicode. And if we run that, we get hello world. And if we kind of copy and paste and we do our own CSI and enhance, then we can see if we got what we thought we got. Where are we at? So hello world, and yeah, that's a snowman. I think that may be one of the old style emojis that are black and white, maybe from like 2010s when it was when emojis were originally standardized and they were all just like really simple characters. But yep, our slides don't lie. That's what we got. Now, what if we change the locale explicitly to be Spanish. And then that's when we get some interesting stuff. So this is, instead of just saying locale.getDefault, we'll say for language tag. Now we use the proper BCP 47 standard for language tags, like Joel explained. So we know what we're going to expect, and inside we're going to just put ES for Spanish and be done with it. Save, run, and we get hello mundo. Can you all see that? Okay. Okay. So yep, as advertised. The recommendations here, Markus, are saying to use Java util locale. Let's use the Java classes for locale.
So it used to be that basically locale was invented at the same time as ICU for J, the locale class in Java, because the ITNN support in the very early days of Java was basically developed by the team that then also published ICU.
So it came from ICU.
Yeah, basically.
Yeah.
And for several years, the two teams worked closely together. What happened then was that we started going from an old-fashioned locale that just had a language and a country or region identifier, and also add support for scripts and other things. We, for example, were grappling at the time with distinguishing the same locale, but with the euro currency versus the older European country currencies. And we desperately needed some way of saying, okay, this is the Serbian language, but Latin letters, or the Serbian language versus Cyrillic letters, or Chinese in traditional versus simplified characters. So we actually helped also create the ISO standard for script codes and put that into the locale syntax and help develop BCP 47 that gives us language tags that can distinguish these things. So we also then developed what we called ulocale in Java as a class that works much like locale but had these additional features. Now what happened over time is that eventually the Java locale was basically upgraded in Java 7 eventually to also include all of this support. So functionally speaking, there isn't a lot of difference anymore between the Java locale class and the ICU ulocale class. We've made an effort to basically upgrade all of our APIs so that there is a version both for locale as well as ulocale, and make them basically interchangeable.
So this story will repeat out for a lot of different functionality. As Markus mentioned, a lot of like the internationalization portion of the Java standard library came originally from ICU. I think Markus has told me the story of how they kind of kept these things in sync in the early days of Java, but over time, ICU was continuing to add functionality, improve functionality at a rate that the Java language maintainers were not keeping up with. So there's a kind of a divergence, and ICU continues to always keep as closely up to date with Unicode data and Unicode standards as possible. So as far as I'm concerned, if you are putting, like my rule of thumb, this is what I tell new Googler hires when I run the the internal training for new hires on internationalizations. I'll say, if you are putting any user-facing text, and that includes numbers and currencies and other things, dates, if you're putting any user-facing text in front of human beings, you should be using the internationalization library, which is ICU. Do not use the internal, string or character methods in your programming language. You will do wrong things very quickly. And you're also guaranteed to have the latest data. So yes, like in certain cases, like the locale class, the Java language may catch up and then reach parity with what ICU has. But there are a lot of things that I think still, if either Java doesn't have it built in, or it's like out of date in terms of data, or the functionality is not all there. So I always say just use ICU if you're doing anything user-facing. And that is a message that cannot be repeated enough. You will be surprised no matter what company you go to, no matter who gets hired. You just have to continue to repeat that message, which is why I think in the previous tutorial that Joel said, internationalization is not a one-time thing. It's not like, okay, we've released our product in these other languages and that's fine. You have new people coming along and they may or may not get the message, and you continue to have to kind of fix things, fight these battles, and improve. So yeah, in the case of eLocale, I mean, I would still say just stick with ICU unless you have a reason otherwise not to. Okay, so here we are. We're hard coding messages. We're also doing string concatenation. Bad, bad, bad. Don't do that. Okay, so let's take a look at this. Bad message dot properties. So here we have a message template, and we're going to have some code that's going to use it. So let's go pop that open and take a look. So we have bad message.properties. Here's that message pattern. It's in a resource file that we're going to use resource bundles, I think, to load. So we're going to get that message pattern. We're going to create a message format object out of that message pattern. So we're going to get the message pattern out of the resource file. We're going to just kind of print it to standard out just to make sure we see what the template looks like. And then we're going to go through all of the entries in this population data. And so then there's this population data helper class over here that will pull all of that data out and give us a set of territory and population for us. So we're going to use that helper class to get the data and iterate over every entry and then print it out with that template. All right, so without further ado, what do we get? The territory of Afghanistan has 34 million something persons, Albania, Algeria, America. Okay, that's looking good. So yep, so far so good, I would say. Oops. The territory of Bouvet Island has 1 persons. That doesn't sound right, right? I mean, ignoring the fact that it says persons and not people. We can do persons, we can do people. I would prefer people, but whatever. The problem is 1 persons is clearly wrong. So yeah, I guess hard coding things isn't always the way to go. But hey, we didn't hard code stuff, we had a template. But our template is not good enough to handle this type of conditional behavior. So there's something going on in the language in which you pluralize different things based on the number. Okay, and I think this is the namesake of Bouvet. Even though he's cropped, we can see his sad eyes. He's disappointed. We need to do better. So CLDR, Common Locale Data Repository, is kind of a project that took all the language, region, locale, specific data and kind of hived it off into a separate project. And that's great because now it's implementation independent, operating system independent, but it also allows the linguists who know about different, the day periods and how time should be formatted, and they know all of the things about the language that CLDR needs, and they go and they talk about and discuss, and they continue to add, improve, and refine through discussion to make sure that this is the most representative thing that they can come to an agreement on. So we have that data in CLDR, and so CLDR encodes the rules for every language about how they do plurals. So in English, 0 dogs, 1 dog, 2 dogs, 3 dogs, 4 dogs. So if it's 1 in English, then we don't add the S. Otherwise, we do add the S. Okay, so there's 2 kind of categories there. Welsh, I don't know how to pronounce that at all, but 0 looks like that for dog, 1 looks like that. Okay, all right. 2 looks like something else. I don't know how to pronounce that either. 3 is back to what 1 was. 4 is like 1. Okay, so already this is not anything I know. And certainly trying to hard code that, you can see how problematic that would be. It turns out that languages do really interesting things. So Welsh, you saw 0, 1, 2 were all different. Those were like 3 different categories. When you look at all the different languages, there are at least like 6 categories of plurals. Like for some of the ones that have the most, I think like Arabic and Russian get up to 6 different ways that you conjugate things for plurals. Or sorry, inflect. So CLDR has the rules, and that's a visualization of what those rules look like. So let's look at this. So this is using the message format syntax, but here we're doing something different now. We have basically kind of a conditional type of thing. Do not use this as a substitute for actual code. But when it comes to the formatting of information based on linguistic characteristics, absolutely do this. So population is a number. And based on that number, we're saying plural. I need to pluralize the message based on what that number is. So if it fits in the 1 bucket for English, then we're going to say the territory of territory has basically whatever that number is, person. Otherwise, we'll say the territory of territory has, and then whatever the number is, persons. Now, it's always good to use the syntax for formatting numbers and to format the number. Don't just like hard code the number 1. Again, hard coding is bad. But why is that also important? Because in some languages, you're not using the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 that we're used to in Latin digits. Chinese has its own digits. Japanese has its own digits. Bangla has its own digits. Arabic has its own digits. So we don't necessarily know what language this template might be used for, this pattern might be used for. And we don't want to assume how that number is going to be formatted in the target language. So definitely use the placeholder for a number as well. So when we take a look at good message, there's that template that we were just looking at, or that pattern that we were just looking at. And here's the code that's going to use it. So it's using the good message resource. But otherwise, everything looks the same. And let's go and give it a whirl. And let's see if we can find, what was it, Bouvet Island? There it is. Bouvet Island has 1 person. Yay. So it did the right thing, but everywhere else, persons, fine. Perfectly fine. I would actually, and here's the unknown region, it has 0 people. That sounds right, actually, in English. So the rules are correct. If it's 1, singular, anything else, you add even if it's 0. All right, so the rules keep us on the right path. And it's great that we don't have to change our code to handle that specifically. It's encoded in the pattern where it belongs. And we get the right results. So what's interesting, like I said, is you don't want to touch the number because you don't know how it's going to be formatted. But what's also nice is that you can change the formatting of the number as well. You don't have to do this hard-coded in code. You can actually just do this within the pattern. So you can be a linguist and translate these patterns from one language to another, and that's fine. If you know what the function names are and what their options are, you don't need to actually write code, and you can get some cool stuff. So let's take a look at this. The room measures, and we have a pattern here. Keen observers might notice a problem with this pattern. Actually, no, this is, yeah, but I'll save that for later. So this is what you get. When you put in 0, you get 0 meters. When you put in 1, you get 1 meter. And then 0 again, 0 meters. All right, that's good. That's fine. But there is something that we could do better. So meter is a unit, and everyone's using this over and over again. We have unit formatting in ICU. So if a unit is attached to a number, that's a unit. And there's all sorts of things that we want to do. We want to calculate, do operations on that, and format. And we want to do this in all these different languages. So it's possible that we don't even need to know what the plural is of meter for a particular number and write this out over and over again. We can actually rely on the library to tell us what that should be. So we can say, give me the number, the first argument. That 0 means just give me the first argument and the arguments list. It's a number, but it's also going to have these options to say that this is a unit, and it's a length unit in particular. And in particular, it's the meter unit. So we're saying this number also has a meter unit, and this is how long I want it. I want the full word. And that's within the the room measures, blah, blah, blah. So let's take a look at that. That's an S88. So we're flipping back to C++. And that's over here. So we have our setup. We have our pattern. This is a helper function that we'll take a look at, but first we'll see where things start. So we start at main, and you can see that this is one way of doing it, where we kind of hard code the word meter, but we are doing at least proper formatting of the number, letting the library handle it for the locale. And then here we're doing the same thing, but now we're fully formatting the unit automatically, letting ICU handle things. And then the first pattern will format with the number 1 and then the number 5, and then we'll do the same thing for the second pattern. So this run function is this helper function, and it basically just does exactly what I said. Sets up the message formatter, and then takes that number and puts it into the args that get fed to the format, and then formats into the result and passes the result back. So let's run this. The room measures 1 meter wide, 5 meters wide, 1 meter wide, 5 meters wide. Now, that's all good, but it gets it gets interesting when you then choose a different language. And I thought that the different language was here. Anyways, somebody give me a language code for another language.
HI.
Okay, I blame VS Code for this. Is terminals do not handle abugida scripts very well. They don't, and so VS Code is just giving you that. I also heard, was it KR?
Yes.
All right, let's try KR. So sorry for that, but I'm used to that. So yeah, welcome to the club. Although VS Code as an editor, in the editor mode, handles abugida scripts pretty well. But this is also Linux, and Linux has issues. So KR is the language code for what? Korean? Okay. Yeah, I should know that. Oh, KO. Okay, I was sorry. Hey, oh. Does that look right? Yeah. All right. So you can see that there's a level of good formatting that we can have, but we can go, the further we go, the more pleasing it is because it's doing the right thing more and more. And you can also see, like, I'm just noticing this on the spot. There's a space between 1 and meters in this wide mode, or this full length formatting of the quantity and the unit. In Korean, I guess there is no space.
Yeah, they don't really use space. I mean,
Okay.
they do, but like numbers, you don't.
Okay, so in this context, they don't use space, so this looks correct.
It's fine.
All right.
Space between 2 letters.
Is there a space right there?
Meatball is 1.
Yeah.
There.
Also, there should be space in front of the.
If you copy it into a regular editor or notepad or something, gedit, it might look better. The Hindi as well.
Oh.
Like Elango said, terminals, because they're fixed with, are not very good. Copy the Hindi too for comparison.
Oh yeah, the Hindi might look proper. All right, so does that look better? Hopefully. Where's our? Yeah, maybe this will come out. Oops. Snag the Hindi. Paste. Hey, all right. So ICU is giving the right thing. It's just that the tools that we use, if they don't properly support Unicode all the way through, then we have problems. Oh, I see a question. So the question was HE. Is that the language code that I?
That's Hebrew. Yep.
Okay. Okay. Yeah. I think you're getting to an area that we don't have time to cover in this particular tutorial, but are we getting, let me copy paste and see if this is the right thing. Now, there's a lot to the BiDi algorithm, and I'll just be honest, I don't know the half of it. And I think Markus does know more, but it's really complicated. I think we're in a left to right paragraph, but we have right to left units formatting. So I'm gonna.
Okay, so now just to be interesting, hit the cursor left button a few times.
So if you haven't seen right to left text before, yeah, this will be fun. All right, I'm hitting the back button, back. So this is not doing the right thing, is it? It's not doing the right thing. So we need a better editor. So maybe Microsoft Word, Google Docs. Again, every part of your stack needs to know how to do the right thing for all these languages. Unicode allows you to do so many things, right? Like it's not just the characters, it's not just the property data, it's ICU that creates algorithms using those characters and property data. But then you need your terminal to then hook into either the layout rendering engine of the operating system, or if you have a browser, then maybe you're laying out things yourself, and you need to get all this stuff correct. And if you don't, if you have a text editor where the cursor tracking doesn't really work the way that it should, then you have these kinds of broken experiences. So is internationalization a done thing? No. Actually, I took a look at, after 10 years working at Google, they give you they give you a little certificate in a frame. I looked at it for the first time a couple of days ago, and I put my name, but then I also put my name in Tamil, the language I speak, which is an Abugida script, and the rendering of the glyphs is broken. So it says my name, Elango Cheran, and then it says my name again, but it's like gobbledygook in parts of that. So, hey, we have a lot of things to fix still. Yeah, the more things that we can encode that are commonly used, but we can have the library generate for us, the more it makes sense that we let the libraries do these things. We can't possibly translate every single number in the world. There's like, how many numbers are there, right? I think it's like a Cantor set, right? Question. Like, how many numbers are there? We can't translate every single number, but we can let the library algorithmically tell us how to format these numbers, no matter what number we throw at it. And that's what these libraries are for. Speaking of numbers, if you've been on websites that want to show how many views and likes and clicks and things, you don't want to see the full number, so we have compact notation. This is really important in those types of places. So let's take a look at that. That's 99. So we have a large number. Now, off the top of my head, 987654321. Is that 9 million? Is that 9 billion? Is that 900? Is that 98 million billion? 987 million billion? I don't know. It's a large number. And I want to format it, but I want to format it in a way that's meaningful for someone to just get a high-level view, like how popular was this post online? So let's take a look at the code. We're going to set up a number formatter. This is a localized number formatter, LNF. So we set it up. Here's the static constructor. We say notation, compact short. You have the compact short object, and the locale is English. All right, so we set up our formatter, do some more initialization, make sure that the setup was okay. All right, always got to check at any time something can go wrong. Check, and when you're doing ICU for C, and let us run it. So let's take this number, that large number, format it with our formatter, turn that into a string and then feed it to cout. Okay, and then that was a two-step process, creating the formatter and then doing the formatting. We can do it all in one if you want, not a problem. And then we print out that number, but then we want to do the compact short notation version of that same number. So we create this other message format object using the pattern. And we think that it should do the same thing, right? Because it's compact short notation here. And here we're saying number formatting with the compact short notation option. So we should expect this to do the same thing. Here we go. All right, so we do get the same thing. But if you are creating message patterns, this is a way that you can access that functionality in a reusable way, and you're going to get the right result. So I guess that's the answer. It's 988 million. I said, what did I say? I said 98 or 987. So why is it saying 988? Rounding. Yep. So it's going to do, and you can choose what rounding modes, but yeah, 987, and then the 6 is greater than 5, so we're going to turn that 7 to an 8.
Can you set the language to Bangla?
What?
Language BN Bangla?
Oh, okay. Boom. So we've hard-coded here English US, and we did it again. But we didn't do it here. We're using the default locale. And then this environment variable allows us to override that. Now, in truth, taking the next step in internationalizing your programs, you wouldn't use an environment variable like this. You would actually have these message patterns bundled off. Like you would have a bundle of all your message strings in BN. And you would translate, you do it in English, you do it in Bangla, you have a bundle for every different locale. And you separate, that way you separate the data from the code. And that's really nice for everybody involved. The code never changes. You have the same identifier of, you know, if I have a button and it's got a label, you give that an identifier. That identifier is constant no matter what language you throw at it. And then you just have to say, this is the language I want, give me that bundle. It loads everything. So that's really the way that you do it. But for the purposes of demonstrating what ICU can do and how, just quickly showing how things look in different languages, we're just kind of using this for now, the environment variable. Break iteration, let's see, how are we doing? I'm going to start to go a little bit faster. But this is a core essential piece of handling text. Like basically, we've got standards of how we take text and break it up. So it's called break iteration, but I think the localization industry terminology is segmentation. I think that's really the more standard way of saying it. So you can segment text into lines, sentences, words. I'll say letters, like for human beings, like letters, what I would equate grapheme cluster. But if you're a script purist, you might say, oh no, it's grapheme clusters. Maybe if you're a font person, you think in terms of glyphs, and you might say it's a cluster of glyphs. But to me, I think the grapheme cluster is designed, the algorithm and the property data are designed to have meaningful units of text for a human in that language. So yeah, of course you'd want that. You have to figure out how to make a cursor go back and forth. You double click on a word and you select the whole thing automatically. And you need to know, like, this is so fundamental to everything that we do on our devices on a daily basis. So this is what it would look like. Now, this is a low-level algorithm, low-level library. Let's see if we can at least get it to run. But this is saying create word instance. We feed it some text, and then we iterate through everywhere that we get a word break. So let's take a look at that. 23, break it, break iterator. So there are a lot of different strings going on in this that are not what was in this hello world example, but let's Let's go for it. First, next. All right. So actually, that was I did not realize that was an interactive way of handling text. So I didn't give any argument. So this was just hello world, how are you? I suppose I could have done UTW 2025. And we're going to get different break positions. All right, so the first one is going to be 0, of course. Where is our next break going to be? 3. And then the next break point, it will be 4 because it's going to be the beginning of the next word. And then the next one, 8. Yeah, 4 plus 4. And then, yeah, that's good. We're at the end. So let's quit. Boom. So that's great. We get the indices. But if you wait for Markus's session tomorrow, he will talk about modernizing ICU. And he and I worked on, at least in Java so far, and we're going to get to C++ eventually, a higher level way of doing breaks where we get the actual strings and we don't have to look at numbers and do substrings. But yeah, that's a break iterator for you. Collation, which is basically sorting, but with a fancy name. And why is this important? Even if you take the Latin alphabet, there are European languages that all use the Latin alphabet, A through Z, but those aren't just A through Z. English has A through Z, yes. There are a lot of languages that use that alphabet but have other letters too, like A with an umlaut, or O with a cross through it, A with a ring on it, E with an accent, acute accent, it's a grave accent. So yeah, there are a lot of letters. And guess what? A is not always the beginning. Z is not always the end. Danish and Swedish and Norwegian, there are letters that come after Z, including A ring. So if you think, and AA is equivalent to A with a ring on it. So if you think that you can just use your programming language and just do string dot, sort or whatever, or have a collection and do dot sort on that collection, you're going to fail so hard, so miserably. And that's where you say, okay, ICU, take the wheel, let me just sort stuff according to the language. You tell what the language is, and it will do the right thing. I was looking at this yesterday, I think Danish and Swedish have the A ring after Z, but they put it not in the same order either. So sure, of course. This stuff gets so tricky once you start looking at the details. But you can imagine that when you look in different languages, sometimes the letter, like in German, like when you look at a dictionary and you see an A and you compare it to an A umlaut, like they sort together. So you ignore the umlauts when you're looking things up. But in some languages, that actually, those accents do make a difference. And I think maybe French in Quebec does really funny things with the accents when you sort and you compare two different words. So it's all sorts of wacky, and collator does that. Markus knows very well about collation. But collation, when you think about the properties that a collator can have, it can ignore these things and it can treat A and A umlaut together. Like that's useful for sorting, but it's also useful for searching. When you think about it, when you are on a web page and you do Control F, you kind of find stuff in the page, even if a letter has an umlaut and you type that letter without the umlaut, it will still match. And so that is a real world case that you can relate to, in which that find functionality is using collation functionality. These things are combined. So the string search API in ICU uses collation information. Oops, sorry about that. But there's other things in collation options that you can give, like you can tell it to, when you see a number, treat the number as a number. Like if you have file 1, file 2, file 3, and then you get to file 10, you don't want the 10 to be alphabetically sorted. You want it to be treated like a number and compare after the number 9. Not like, oh, well, 1 comes before 9, so that's going to come after. You've ever had that problem? Mac OS does this nicely. They're probably using collation and turning on that flag that says treat numbers like numbers. But yeah, you can ignore case, you can choose to include case, et cetera, et cetera. There's a lot of stuff going on there. So we have an example here. Let's take a look at that. Collate message. So now we're going to compare these things. And so previously we were comparing based on the name of the territory. And I think that's what this comparison is too. We're creating a tree set. So now we're having an ordered set, not an unordered hash set. The comparison function says, given two entries, let me compare based on the name of the territory. And so if I run this, then I think it's similar to before. Everything is in alphabetical order based on the territory name. I wonder, I am going to ad lib here and see if we can do something different. No, I can't. No, you can only compare strings. You can't compare numbers. I wish I knew how to play around with this. Maybe I can play around with the default locale.
What are you trying?
I'm trying to see if I can get a different ordering of regions. So yes. So here it's like if you play around with the locale, then you're going to get different results. Unfortunately, I can't verify. I can maybe look at the Spanish and see that maybe these words are different. But yeah, let's just at least try it out. So Russian for language tag, are you? Save, run. And I presume, I mean, you can see if you look at just the first letter of these regions, you can see that it's sorted by the Cyrillic name. And it's very different from what it would have. It's a completely different order, but it's doing the right sorting. But collation gets really tricky really fast because you have ideographic languages. How do you sort that? And there are a couple ways to do that. And all of that works automatically because we've got the character properties, and Unicode contributors take a lot of time figuring out what those values should be for every single character in Unicode so that this collation algorithm that Markus has done a lot of work implementing in ICU over the years can be agnostic to all of that information and just it does the right thing. And when there's a bug in the data, they go fix it, and magically the code stays the same. We have a bug fix in the data, ICU inherits it, and we have a better product that everybody gets to use. So that's pretty cool. Okay, so I think we're getting to the end, and that's good, so we can have time for a few questions. ICU is used by everybody. It has to be stable. Unicode also has a lot of stability principles so that people can rely on this. If you have a moving target, if you build a house on sand, like it's just not a stable foundation, and it's just going to be a huge mess. So like I said, ICU makes sure that to the extent possible, it does not change things up on people. When you do have a new API, you kind of put it in technology preview, you mark it. Or if something is ICU internal, you say internal so that people don't rely on it. It's like, hey, this thing is going to change on you, no promises. When things are looking good and we want people to comment, we'll say it's draft. And there's a whole process for contributing to ICU that makes sense for. And when everything is good to go and it's the final version, we say stable. So it's a big deal to get to stable because once it's there, it's there. Sometimes things are not useful anymore, and then we deprecate. Like ICU used to have a layout engine in it, but now people use Harfbuzz to do their layout engine. So if you're creating a browser and you want to render your fonts glyphs properly, you kind of use that. So that's an example where if we haven't deprecated it, it's a question, should we deprecate? So that's the kind of stuff where it's like, don't look at this anymore. To find more information, go to the ICU user guide. You can see the stability mentioned in the API docs as well. So here it says internal, do not use, internal use only. Here's a draft, may change in the future. And then eventually it gets to stable. And then we say what version it became stable in. Binary stability, Markus mentioned that, if you're using C, then you have stable ABI. again, all this is just to make things as convenient and as seamless and as easy as possible. Serialization compatibility, IC4J. Yeah, I think that's true. There's a whole topic that we can't get to about resource bundles and data files. ICU's resource bundle is highly optimized to be incredibly performant for the data that it stores, and to serialize things so that you don't allocate unnecessarily. So it's really just so many features of ICU that have been looked at by people like Markus have been optimized so well so that things are just incredibly fast. This is a reflection. So when we look at the features and locales, some locales have a lot of features, a lot of people, a lot of data that they can contribute, and it makes it into CLDR. And then it comes into ICU. ICU just inherits it. But there's still a lot of languages and locales, languages and regions that don't have as much data contributed to it for whatever reason. So there's a lot of work to do to increase the presence of languages in technology. But once they're there in CLDR, and then we can automatically inherit them into ICU. So packaging up ICU, there's a whole build tool, and some people don't need all the data, and they think, oh, well, the data is a huge component of that. You have, for every single region in the world, you have how to display that name in every language in the world, or every locale in the world. That's a lot of strings, right? So some people may not need that. They kind of slice and dice, and we have a tool for that. And there's more information about how to package up data and customize things. It's like, I don't like the way that this region is, this region's display name is, I don't like that display name. All right, then you can download the data. You can download ICU and you can build that data, customize it yourself. And then now you have your own version of ICU with your own custom version of data, and we're all happy. So that's good. This is just a diagram explaining that data changes over time, and really depends on what version of a CLDR and that Unicode's pulling in at this point, and what version of Unicode is going into ICU. At this point, at least CLDR versions are like, the ICU version is 30 plus the CLDR version, and then Unicode versions increment one a year. So Unicode has its own stability policy. So Unicode is its own set of data, like all the property data, the Unicode character database, locale data. Yeah, and things just change over time. Like, how we format dates in Canada might be more like America. I think that it used to be more like Britain, and now it's more like America, and so then they changed that in CLDR data. But yeah, don't try to parse. That tends to be bad. General rule, like, when you have computers communicating to other computers, you store things for the purposes of like a database. Do not use localized information. Using ICU to localize a string is only when it gets to a human's eyeballs, and not a moment sooner. So yeah, don't store localized data on disk. And there are some bugs that have happened because people didn't know any better. Yeah. So yeah, property data can change. So making assumptions about characters are also another thing. So I think, yeah, when in doubt, use the ICU version of classes. And this is how some of these things compare. So here's some recommendations about what to use or what not to use. In this case, I think use the Java math big decimal, but for everything else, there's a doubt, use ICU. You can get involved with joining our mailing lists. And here's information to get in touch with me, Markus. Stephen Loomis wrote these slides originally, so big shout out to him for that. And Craig and Shane have presented this session previously, so their contributions are here as well. All right, thank you, everybody. We have 1 minute left for questions. I'm sorry, but I'll obviously stay around for questions throughout the break, throughout lunch. Just find me. Is there a burning question that you think would be really interesting for someone to ask for the benefit of all of us?
Question about plurals. So, what do you do with a language like Japanese where it's not about how many things there are, but what exactly you're counting? So, for example, if it's like a flat object, you use this counter. If it's like a big object, you use this counter. Would you categorize that in terms of units more so than?
Oh, that's a good question. So the question was Japanese, where the word that you use to pluralize something, actually, there's like a word that you use in addition to the number that goes along with the category of that noun. So someone explained this to me in terms of English. It's like when you talk about corn, you always talk about ears of corn. And it's like, what is an ear of corn? But we call it ears of corn, but it's just like corn things. But you just say it. And Japanese is full of that. And there's like a whole ton of these types of words in Japanese, and you just have to know it. It's part of the language. I think that's more of a message thing. I don't think that you're going to have like, that's more of like, what is the rest of the message about? So I think it's a very contextual thing that depends on the message. But this is another reason why when you author these messages, don't string concatenate. You translate the whole message at a time. Do not insert a message inside another message, because you're going to get, that's effectively string concatenation when you have a message inside another message. So in the new version of message format 2.0, we kind of make sure that you don't have that string concatenation. So stay tuned for that. I don't know if there are talks that we've had at UTW in years past about message format 2.0, and that standard is still evolving. So if you want to try that out in your systems and get feedback, there's never, the moment has not passed you by. There's always an opportunity to let them know. All right. We're out of time, but I will take this question after. But thank you all for attending.